Let's do a voltaic cell problem. This one comes from the practice test. So if you have done that or haven't done that, then you can use this as an example. So what we have here is gold and gold ion and iron 3 plus ion, and we're going to set up a voltaic cell between them. The first thing you're going to have to do is look at a standard reduction table and find which is going to be the oxidation and which is going to be the reduction, and you're going to base that on which one is higher on the chart and which one is lower on the chart. The higher one on the chart is the reduction. It's going to remain the reduction. The lower one on the chart is going to be the oxidation, and so look at a standard reduction table. On the standard reduction table was that gold was higher. So gold is going to be written just the way it is on the standard reduction table, as Au plus 3 electrons yields gold solid. And then on the standard reduction table, you saw that iron was further down. So then iron is going to be written in the reverse order. Hold on, let's put the voltage for gold up there. It was positive 1.50 volts. The iron, you're going to reverse everything about it. So it's going to be Fe becomes Fe plus 3 electrons at, now on the table it was negative 0.04 volts. We are going to, since we reverse the reaction, reverse the sign on that. It's going to be positive 0.04 volts. And then we can add all that together to get our overall reaction. It's going to be, the electrons have to cancel, and since it's 3 on the reactants and 3 on the products, it does. We've got then gold ion reacting with iron metal yields solid gold and iron ion at a voltage of positive 1.54 volts. So I think one of your first questions was the overall reaction. A follow-up question would be the overall voltage. So there's that. What is being oxidized and what's being reduced? Well, gold is going from positive 3 down to 0. So gold, right, it's also gaining electrons. So the gold is being reduced and the iron is being oxidized. That would make the gold side, so it is taking electrons in, plus you can remember the little acronym NOx red cat. Either way you slice it, electrons are heading towards the gold, and that makes it the cathode. Electrons are coming out of the iron side. It's the oxidation, it's losing electrons. It's also undergoing oxidation, that makes it the anode. So this guy is our anode, and electrons are going to be flowing that direction. And what is going to be happening in these bodies of solution? Well, let's look at the overall reaction. You have gold ion becoming solid gold. So on the gold side, you're going to have the ions from this solution globbing onto the electrode. So the cathode is going to be gaining mass because ions are coming out of solution and globbing onto that electrode. On the iron side, you have, let's look at the overall reaction. You have iron becoming iron ion. So you will have this electrode, this piece of metal, breaking down ion and the metal becoming ions, and that ion solution will be becoming more concentrated. So the anode is going to lose mass, the cathode will gain mass. This ion solution on the cathode side will become less concentrated, and the ion solution on the iron side will become more concentrated. So that hopefully answers all of the questions that anyone could ask about a voltaic cell.